Let's take a look at configuring a operational amplifier. Now, there's just two rules. The input draws no current, so no current flowing into the operational amplifier in an ideal situation. And the output attempts to make the voltage difference between the two inputs zero. So if you put in 5 volts on 3 here, the output tries to make pin 2 at 5 volts also, okay? Now, in order to power these up, I'm running a dual power supply. So I'm just using two 12-volt batteries. I have the negative and positive tied together, and that's going to be our ground. And all our voltage readings are going to be taken from that point. And then we have our positive voltage over here and our negative voltage. And the positive goes to pin 8, and the negative is going to go to pin 4 there. And this way we can get a swing from negative and positive voltage. So the first one here is a non-inverting amplifier. So, and this one I'm putting in 5 volts on pin 3. And so the output wants to make pin 2 at 5 volts, but it goes through a voltage divider here, these two 10K resistors. I'm using all 10K resistors. Now you can change these up, you can change the gain on the unit by changing these resistors here. And here's the formula for gain. And in this case, the gain is going to be 2. And here's the formula for the V in and V out here. So, but we can see if we put 5 volts here, we need to have 10 volts on the output because we're going through a voltage divider, and that's going to give us 5 volts on pin 2. Then these two are going to cancel out, and the unit's going to be happy. Now, for an inverting one, we take pin 3 and we ground it. That's grounded. So there's no voltage on there. And we're putting in 5 volts into pin 2 here. Now, we want pin 2 to be 0, so in order to make that 0, and it goes through this voltage divider, we need to put negative 5 volts on this side. So we're going to put a negative 5 over here, positive over here. Those two are going to cancel out, and this is going to be 0, and that's going to be 0. So that's our inverting amplifier. We're going to get negative 5 volts out of it. For a differential amplifier, it's hooked up this way, and here's the formulas for it. And what happens here is on pin 3 here, we're putting 5 volts on pin 3, but through a voltage divider. So I'm putting 2.5 volts out here. And then I'm putting 2.5 volts into pin 2 here, but that's going through a voltage divider. So that's going to cut that in half. So we need to put another 2.5 volts over here in order to make this 2.5 volts, okay? So this one's being cut in half. This is also being cut in half through the voltage divider. And we need this pin 3 to be is going to be 2.5 volts. We need pin 2 to be 2.5 volts. So our output's going to be 2.5 volts, and that happens to be the difference between the two inputs here. Of course, you can change the resistors here and change up how you want to divide that thing up or subtract that. Take a look at a summing amplifier. It'll add these two voltages together. Now, what happens here is we have pin 2 is grounded, and this is a non-inverting summing amplifier. Pin 2 is grounded, and we're putting voltage into pin 3 here. Now we're putting 5 volts in this one, and another 2.5 volts on these two resistors right here. They're both 10K resistors. So at pin 3, we're going to actually get 3.7 volts, okay? Now, in order to get 3.7 volts on pin 2, we have a voltage divider here. We got going to ground here, so we need to have 7.5 volts coming into here to get our 3.75 volts on pin 2 here. Now, this the way we get these add up together, we use KCL, Kirchhoff's current law, and I'll put out another video on how you actually do the math to get the 3.75 volts over here on pin 3. But it just tries to get this the 3.7. It tries to get this pin to be 3.7, and it goes through a voltage divider, so it has to be 7.5, and that's going to add our two units together, our two inputs together. So let's take a look at these units here, and we'll see if we can get it to work here. Here's our voltmeter. We'll turn some power on here, and this is I'm using these batteries here for my 12 volts. And can we see yeah, I think we can see that. So this one here is this is the non-inverting amplifier. So on pin 1 here, what do I want to get? Let's see if I can get. So this is the this is the inverting amplifier. Let me get this out of here. So this one's the inverting amplifier. So I should have negative 5 volts on pin 1 here, which I've got negative 5 volts on that. Now this is my non-inverting amplifier, so I should have 10 volts on pin 1, which is close. And this one is my I think this is the differential one. Yeah, and so on the differential I should get 2.5 volts out on pin 1, which I'm getting 2.499, yeah, 2.5 volts on pin 1 here, so that one's working. And this one down here is going to be the summing amplifier, so I should get 7.5 volts on that. 7.58 volts, something like that. And where's my, on pin 3 here, let's see what we got on pin 3. I have 3.7, should be 3.75, 3.71 volts on pin 3 here, between these two. On this one here, this resistor here, I have close to 5 volts, and this one here I should have 2.5 volts on there, so that's close. So, but I'll explain how you get the when you're putting in 2.5 volts on this 10K and you're putting in 5 volts on this 10K, you get get this on the right pin, 3.75 volts out on out of those two, that junction there. So that's operational amplifiers, and thank you.